Hello friends, let's start off with exercise 7.4. So in this you have previous exercise we have seen what is permutations 7.3. We did all permutation problems. Now we'll be doing all combination problems. So how to do this problem we'll just see, and we'll just go into the review of all the formulas which we are doing. What are all the different formulas we were having for permutations we'll see, and then we'll come back to this. So first here what is given in this problem we'll just see. It's given that if NC8 is equal to NC2, find NC2. Here C is nothing but combination. So this is a combination problem. So it's given this. But before going into this problem, we'll just see what are the different formulas we learned for permutations. NPR is equal to n factorial by n minus r factorial. This formula we learnt previously, and we did all the problems using this formula. Now here what is NCR equal to, we'll see. NCR is equal to nothing but n factorial divided by r factorial into n minus r factorial. So the basic difference between NPR and NCR is in the denominator we are having an r factorial. So therefore we can write this as equal to, it's equal to NPR divided by r factorial. This we can write basically, this is equal to NCR is equal to NPR divided by r factorial. And also we have here that suppose we are having 5 NCR, this is equal to nothing but NC n minus r. How means, now this is when we are taking here, suppose you are having either a combination of these two, that is the base whatever we are writing here r and n minus r, these have to, when you're adding both of them, it should be equal to this what we are writing in the this part, that is n. It should be equal to n, that is r plus n minus r is equal to nothing but n. Like suppose if we are taking one example, suppose we are taking it as 5. For example, if we take NC3 is equal to NC2, then we have n is equal to nothing but 3 plus 2, which is equal to 5. Have NC4 is equal to NC2, then n is equal to 4 plus 2. So this is the way we find out how we get n. So n will be equal to 4 plus 2 over here, which is equal to 6. Now going into the problem. So now what is given to us, we have NC8 is equal to NC2. So now how do we write this? N is equal to, from the is equal to 8 plus 2. So therefore n is equal to 10 we got here. So therefore here you can take, now when you're comparing this, NC r is equal to NC n minus r. Here r is, if you are comparing these two, that means if you are comparing, compare with NC8 equal to NC2. So what are we having over here? We are having that r is equal to 8. If you compare these two, from this you get r is equal to 8, n minus r is equal to 2. So therefore now you put in this place 8. So n minus 8 is equal to 2. So from this also you are getting n is equal to 10. So therefore from both of them you can either do in this way or you can do it in that way. So therefore you are getting here n is equal to 10. So now we'll put what we have to find out, NC2. So therefore NC2 is equal to nothing but 10C2. Now using the formula, NCR is equal to n factorial divided by r factorial into n minus r factorial. You're getting 10C2 is equal to 10 factorial by 2 factorial into 10 minus 2 factorial, which is equal to 10 factorial divided by 2 factorial into 8 factorial. So therefore this you can write it as, 10 into 9 into 8 factorial divided by 2 factorial, that is 1 into 2 into 8 factorial. So these two are getting cancelled. So which means here you are getting 2 5. So therefore the answer which you are getting here is 45. So here is equal to 45. That means 10C2 is nothing but equal to 45 is the answer. This is the answer which we got here now. That is NC2. In the second problem, determine N if 2NC3 is to NC3 is equal to 12 is to 1, and second one 2NC3 is to NC3 is equal to 11 is to 1. So now we have to use for the solution problem what is given in the first one. We'll just write here 2NC3 is to NC3 is equal to 12 is to 1. So now we'll use the formula. We're having NCR is equal to n factorial by r factorial into n minus r factorial. So therefore you're having 2NC3 divided by NC3 is equal to 12 by 1. So now we'll use this formula which we have written here. That is nothing but 2n factorial divided by 3 factorial into 2n minus 3 factorial divided by n factorial by 3 factorial into n minus 3 factorial, which is equal to 12 by 1. So now this can be written as, how do we write this? It writes 2n factorial divided by 3 factorial into 2n minus 3 factorial. Now this is in the form of a by b by c by d, which is equal to, you will get it as ad by bc. So using this, now this will become multiplication of 3 factorial into n minus 3 factorial divided by n factorial. So therefore now here you can cancel out this 3 factorial. So now which is equal to 12 by 1. So now this you can write it as, now you are having here, how can you write 2n factorial? 2n into 2n minus 1 into 2n minus 2 into 2n minus 3 factorial. And in the denominator we are having 2n minus 3 factorial. So into, here you are having this n minus 3 factorial divided by, here you can write it as n into n minus 1 into n minus 2 into n minus 3 factorial. So this and this will get cancelled. This and this will get cancelled. So this is equal to 12 by 1. We have it. Because you know that 5 factorial is written as how 5 into 4 into 3 into 2 into 1, isn't it? So in that same way your n factorial or n minus 3, n factorial will be written as, n factorial will be written as n into n minus 1 into n minus 2 into n minus 3 factorial. So on you can write down this. So now here you get in the next step here, you get it as 2n into 2n minus 1 into 2n minus 2 divided by n into n minus 1 into n minus 2 is equal to 12 by 1. So now here you can remove this n can be cancelled out. So here you can take out 2 into 2n minus 1 into, here you can take out 2 common, isn't it? So you'll get n minus 1 in the bracket divided by n minus 1 into n minus 2. So therefore this will get cancelled here, which is equal to 12 by 1. So here you are getting here 4 into 2n minus 1 by n minus 2 is equal to 12 by 1. So now you can get here again 8n minus 4 into cross multiply. If you do, you are getting into 1 into 12, here is equal to 12 into n minus 2. So which is equal to 8n minus 4 is equal to 12n minus 24. So therefore this will become here, bring all the terms to one side. So here minus 4 plus 24 is equal to 12n minus 8n. So which implies that, so 4 minus it become 20 is equal to 4n. So n is equal to 20 by 4, which is equal to 5. So n is equal to 5. So therefore here the answer which we got is determine n. So we got the n value as equal to 5. So now what is the second question? We'll see. 2nc3 is to nc3 is equal to 11 is to 1. So again we'll write down what is using the formula. 2nc3 by nc3 is equal to 11 by 1. So now we'll expand this. How do you expand this? 2n factorial divided by 3 factorial into 2n minus r factorial. Using the formula, we are using ncr is equal to n factorial by n factorial divided by r factorial into n minus r fact. So now then divided by, here we wrote using that formula, so this divided by n factorial divided by 3 factorial into n minus 3 factorial, which is equal to 11 by 1. So now this can be written as equal to, here you can write this as, if you write it here, you can write this as 2n factorial divided by 3 factorial into 2n minus r factorial into 3 factorial into n minus 3 factorial divided by n factorial, which is equal to 11 by 1. I told you that if a by b by c by d is written, you can write this as ad by bc. So that will be written here now. So now here you are getting this 3 will get cancelled. So now here you can write this as 2n into 2n minus, here r is nothing but what we have r, we forgot to write, this is 3. So therefore here also you get it as 3. So therefore 2n minus 1 into 2n minus 2 into 2n minus 3 factorial divided by 2n minus 3 factorial into, here you are having n minus 3 factorial divided by n into n minus 1 into n minus 2 into n minus 3 factorial, which is equal to 11 by 1. So this will get cancelled and this will get cancelled over here. So you can write this as 2n into 2n minus 1 into 2. I am taking out here n 2 common in both of them. So I have written it in this way, divided by n into n minus 1 into n minus 2, which is equal to 11 by 1. So now you can cancel out this and n minus 1 also will get cancelled. So you are getting again here 4 into 2n minus 1 divided by n minus 2 is equal to 11 by 1. So therefore this will be equal to 8n minus 4 divided by n minus 2 is equal to 11 by 1. So this will, if you cross multiply, you will get it as 8n minus 4 is equal to 11n minus, or you can take it as 11 into n minus 2. So therefore 8n minus 4 is equal to 11n minus of 22. So bring everything to one side, you are getting it as minus 4 plus 22 is equal to 11n minus of 8n. So you are getting here 20, so this is 18 is equal to, here this is 3 3n, this is 3n, so n is equal to 18 by 3, which is equal to 6. So therefore n is equal to 6 is the answer. How many chords can be drawn through 21 points on a circle? So now here solution. So now on a circle here, if you are taking 21 points on the circle, how many chords can be drawn? Now when you are taking a circle, chord can be drawn through only 2 points, isn't it? So only through 2 points you can draw chords. So now we have to select over here. From we are selecting here, we use combination. For selection, you know that we'll use combinations. For arrangements, we use permutation. So now we have to select over here 2 points for drawing chords over here. So from any 2 points we can draw your chords. So in how many ways can it be done? And here we have to always remember where we have to use selection and where we have to use arrangement. So where selection means always you can see that whenever we have selection is coming, it is nothing but combination, and whenever we have arrangements, it is permutations. So now here we'll use combinations in this case, because we are having here we have how many points on the circle. Number of points on the circle is number of points on the circle is equal to how much? 21. And to draw a chord, number of points needed or selecting points for drawing a chord is equal to 2. Okay, so therefore here NCR is equal to, here we are going to select from 21, we are going to draw a chord selecting 2 points. So this is equal to, we know NCR formula is equal to nothing but n factorial by r factorial into n minus r factorial. Using this we can write here 21 factorial divided by 2 factorial into 21 minus 2 factorial. So which is equal to, you can write this as 21 factorial divided by 2 factorial into 19 factorial. So which is equal to 21 into 20 into 19 factorial divided by 22 factorial into 19 factorial. So these two will get cancelled. So therefore this, and here 2 factorial is nothing but 1 into 2 you can write. You can write 21 into 20 divided by 1 into 2. So this will become 2 tens. So 210. So 210 chords can be drawn from a 210 chords can be drawn through 21 points of a circle. Drawn through 21 points of a circle. So here you can see how many chords and how we can draw. Taking 2, you can draw it in this way. Wherever you are having these points, you can join them all this. So in this way, when you are drawing these chords, so you get here, there are so many combinations, 210 combination we can draw chords taking 2 at a time. Okay, now this is the answer, 210. So we'll go into the next problem. So fourth question, in how many ways can a team of 3 boys and 3 girls be selected from 5 boys and 4 girls? So now here, because it's again selection over here, you can see in the problem, so we'll be using here combination. Since selection is there in the problem, we'll be using combination. So now we have to form a team where 3 boys and 3 girls can be selected from 5 boys and 4 girls. So 3 boys, a team is to be selected in such a way that 3 boys can be selected from 5 boys. How can we do that? And there's one more team. This is the first team. Then the second team. In this also you're having 3 girls can be selected from 4 girls. So now this can be done, the first one can be done, this can be done in 5C 3 ways, and this can be done in 4C 3 ways. So now by using the principle of multiplication or multiplication principle, we can write this as principle. Because we are selecting in two ways, these both our selections have to be done. We can do it in 5c3 into 4c3 ways, which is equal to 5 factorial by 3 factorial into 5 minus 3 factorial into 4 factorial by 3 factorial into 4 minus 3 factorial. So now this can be written as 5 factorial divided by, so 5 factorial by 3 factorial into 2 factorial into 4 factorial divided by 3 factorial into, here you are getting it as 1 factorial. So now here how do we cancel this? We can write this as 5 into 4 into 3 factorial divided by 3 factorial into 1 into 2 into, here this can be written as 4 into 3 factorial divided by 3 factorial. So 3 factorial and 3 factorial get cancelled, 3 factorial and 3 factorial get cancelled. Here 2 2s are, so therefore 5 8s are 40. We got the answer. So there are 40 possible, how many ways means in 40 ways, in 40 ways a team of 3 boys from 5 boys and 3 girls from 4 girls can be selected. In 40 ways we can select this. So now here what you are having, here you are having find the number of ways of selecting 9 balls from 6 red balls, 5 white balls and 5 blue balls if each selection consists of 3 balls of each color. So now here we have to select how many balls totally? We have to selecting 9 balls. In what way can we select these? We'll just see. So in the solution, what are the number of balls of each color? So we are having red balls, how many balls? We are having 6 is equal to 6. Then white balls is equal to 5. Then blue balls is equal to 3. So now here 3 balls of each color. That means you are having from totally the red balls 6. So you are going to select 3 of this color, 3 of white color, 3 of blue color. So selecting 3 red balls from 6 red balls can be done in how many ways? 3 ways. Next, selecting 3 white balls from the total number of white balls, how many? 5. From 5 white, and it can be done in 5c3 ways. Next, selecting 3 blue color balls from total number of blue color balls is how much? 5 blue balls, and this can be done in 5c3 ways. Now we have to select of all these 3 colors, that is 3 balls of each color. We are selecting 9 balls, isn't it? So the 9 balls are selected in how many ways? Using multiplication principle. The 9 balls, 3 of each color can be done in equal to how many ways? We'll see. It is 6-3 into 5c3 into 5c3. So therefore you can get this as, you can write this as 6 factorial by 3 factorial into 6 minus 3 factorial into 5 factorial by 3 factorial into 5 minus 3 factorial into 5 factorial by 3 factorial into 5 minus 3 factorial. So now here we can just see what all we can cancel. First write down this 6 factorial by 3 factorial into 3 factorial you're getting into 5 factorial by 3 factorial into 2 factorial into 5 factorial by 3 factorial into 2 factorial. So therefore this can be written as, here you can write this as 6 into 5 into 4 into 3 factorial divided by 1 into 2 into 3 into 3 factorial into, here you can write this as 5 into 4 into 3 into 2 into 1 divided by 1 into 2 into 3 into 1 into 2. Here also the same, 5 into 4 into 3 into 2 into 1 divided by into 2 into 3 into 2 into 1. So now here you can cancel out this 1 into 2 into 3 and this will become 2 2s are, and here again you can cancel 1 2 3, here 2 2s are. So you're getting here 5 2s are 10, 5 2s are 10, 10 10s are 100 you got still now here. Now this 3 factorial will get cancelled here. Then you're having 3 2s are, then here 2 2s are. So you're getting here 5 4s are 20. 20 into 100. So you can write here 20 into 100, that is equal to 2000 ways. So selecting this, it can be done in 2000 ways. So now we'll go into the next problem. So this can, number of 9, the 9 balls, 3 of each color can be done in 2000 ways. So the answer is here 2000. Next, going the so now going into the sixth problem. First we'll read what is the problem. Determine the number of 5 card combinations out of a deck of 52 cards if there is exactly one ace in each combination. So now in this we have total cards 52 and we have to select how many cards? Select 5 cards. So now there is exactly one ace in each combination. So you know each combination 13 of each we are having, isn't it? So you are having one ace in this, one ace in this, one ace in this, one ace in this. You are having all the 4 types. One is clever, diamonds, hearts and spades. So one ace in each type you are having. So now here, so aces you have to select, that is exactly one ace in each combination means. So now here you have to select aces is equal to 4. Okay, since you are selecting all the aces, the total cards left will be equal to how much now? Total cards left will be equal to 52 minus 4 because you are removing the aces, that is 48. So now from the remaining what are we having here, from these 4 aces you have to draw one. It should be, if there is exactly one ace in each combination. So you have from the 4 aces you have to select one card. That means it should be compulsory an ace. And from the 48 cards, the other you have to have the other 4 cards. So now here, so one ace is selected from 4 aces. Can be done in how many ways? It can be done in 4C 1 ways. And again now you are having the remaining 4 cards are selected from 48 cards. In how many ways can it be selected? 48C 4. So now using multiplication principle we can write 4C1 into 48C4. So this is equal to, here you have, again we have to use NCR formula itself. So n factorial by r factorial into n minus r factorial. So you get 4 factorial by 1 factorial into 4 minus 1 factorial into 48 factorial divided by 4 factorial into 48 minus 4 factorial. So which is equal to 4 factorial by 3 factorial into 48 factorial by 4 factorial into, here you are getting it as 44 4 factorial. So which is equal to 4 into 3 factorial divided by 3 factorial into 48 into 47 into 46 into 45 into 44 factorial divided by 4 factorial can be written as 1 into 2 into 3 into 4 into 44 factorial. So this 2 will get cancelled. So now here you will be getting it as 3 factorial and this will get cancelled. So you can cancel this 4 and 4. Here you can cancel 3 1s are, 3 6 are, then 2 8s are. So you are getting here 8 into 47 into 46 into 45. So now you multiply all these using your calculator, you are getting 7783220. This is the answer which we are getting. So now next. So now here you are having in the 7th problem, in how many ways can one select a crease? Whenever it is selection, you know that's combination. So in how many ways can one select a cricket team of 11 from 17 players in which only 5 players can bowl, if each cricket team of 11 must include exactly 4 bowlers? So now here first we have to understand this problem and then do this problem. What is given exactly in this? So what all is given, we'll just see. So now cricket team consists of 11 players, isn't it? So 4 bowlers should be there. So now how many are left over? 11 minus. So now here you have from 17. So you are having here, so 11 from 17 players we have to cancel. So you are having again here 5 bowlers, 4 have to be selected. Okay. So totally now here what you are having, if you minus 11 minus 4, how many you are left over with? You are left over with 7, isn't it? Now here, so now here we are having total number of players are 17. Okay. So from this we have to select 11 players have to form a selection of a cricket team of 11 players. Selection of cricket team of 11 players from 17 players. So how are we selecting this 11 players? So now it is given that here in which only five players can bowl if each cricket team of 11 must include exactly 4 bowlers. So they are out of the 17 you're having. So in this 11 team which we are selecting, here we are having 4 should be bowlers completely. So out of the 17, now here when you're having 17 players, you are selecting 11 out of them. Okay. Now 11 minus 4, and this 4 bowlers can be selected from 5 bowlers. Okay, because the 4 should be compulsorily included. 4 bowlers should be included in this. So now how many are left over here? 7 players are left over. And here how many players? 17 minus 5 is equal to 12 are left over, because 5 of them are bowlers, the remaining all are all-rounders. So 12. Now how can we select this in this way? We'll just see. So the cricket team consists of the cricket team of 11 players consists of the following selection. So how is the selection done? We'll see. 4 bowlers actually it is. 4 bowlers from 5 bowlers. In how many ways can it be done? 5C 4 ways. And then the remaining, how many are left over? 4 are already selected, because we have to have 11 players totally. 4 are selected, means how many are there? 7 players can be selected, because 5 are bowlers. You remove from 17 the 5 bowlers. How many are left over? With 12. So from 12 players can be done in how many ways? 12C 7 ways. So by multiplication principle, how can we do this? Principle, we can write this as 5C4 into 12C7. So which is equal to 5 factorial by 4 factorial into 5 minus 4 factorial into 12 factorial by 7 factorial into 12 minus 7 factorial. Using NCR is equal to n factorial by r factorial into n minus r factorial. We are using this formula and we are writing down this. So this is equal to 5 factorial by 4 factorial into 1 factorial into 12 factorial divided by 7 factorial into, here you are getting 5 factorial. 12 minus 7 is nothing but 5 factorial. So this 5 factorial and this 5 factorial will get cancelled over here. So we'll write the remaining. Here you are getting 1 by 1 into 2 into 3 into 4 into, here you are getting 12 into 11 into 10 into 9 into 8 into 7 factorial divided by 7 factorial. So this and this will get cancelled. Here you are getting 4 2s are 8, it's getting 2 2 will get cancelled. Here again 3 3s will get cancelled. So when you multiply over here, what is the total answer you are going to get here? We'll just see. It is 12 3s are 36 into 110. So 110 into 36, how much you are getting? We'll just see what is the answer we are going to get. This is 3960 is the answer. Now we'll go into the next problem. So now in question 8, what you have? Problem 8. A bag contains 5 black and 6 red balls. Determine the number of ways in which 2 black and 3 red balls can be selected. So now here first we'll, here definitely because selection is there, we have to use combination, that is very clear. So now we'll just write down what are the number of total black balls which are there. So total black balls is equal to 5, and total red balls, how many you are having? Red balls is equal to 6. So now we have to select it. 2 black and 3 red balls can be selected. So 2 black selected from 5 black balls. In how many ways can be selected? 5 C2 ways. Then we have 3 red balls can be selected from 6 red balls is equal to 6C3 ways. So by multiplication principle, we'll write down here what do we get. It's equal to 5C2 into 6C3, so which is equal to 5 factorial. So 5 factorial by 2 factorial into 5 minus 2 factorial, which is equal to 6 factorial by 3 factorial into 6 minus 3 factorial. So here 5 factorial by 2 factorial into 3 factorial into, this is into 6 factorial by 3 factorial into 3 factorial. So which is equal to, here you are getting it as equal to 5 factorial by 1 into 2. Here, so here you will get it as 5 into 4 into 3 factorial divided by 1 into 2 into 3 factorial into 6 into 5 into 4 into 3 factorial divided by 1 into 2 into 3 into 3 factorial. So 3 factorial will get cancelled. 3 2s are here, 2 will get cancelled here. 3 factorial will get cancelled here. 2 2s are 4 you will get. So 5 2s are 10 into 5 4s are 20. So which is equal to 200 ways this is selection can be done. So 200 ways this can be done. This bag of contains 5 black and 6 red balls. The number of ways in which 2 black and 3 red balls can be selected is, in how many ways, is 200. So now one will see, in how many ways can a student choose a program of So here, in how many ways can a student choose a program of 5 courses if 9 courses are available and 2 specific courses are compulsory for every student? So here now we are having, in this you are having total number of courses which you are having. So program of 5 courses if 9 courses are available. So total number of courses is equal to how many? 9 courses over here. So you have to, can a student choose a program of 5 courses and if 2 specific courses are compulsory. So 2 of them are compulsory. So now among all the subjects which you are having, 2 of them, that is math and English, are fixed. The remaining all you can select the other remaining. So from 5 you are removing 2. So out of, first you have to select 5 from 9 and 2 of them are compulsorily from this. So if you remove 2 from this, so the remaining here which are left over is 3. Total courses are C1, C2, C3, C4, C5, C6, C7, C8, C9 are there. Now suppose here C1 and C2 are compulsory. These are compulsory. So now these 2 are compulsory and the remaining what are left over here, 1, 2, 3, 4, 5, 6, 7. So now this, from this 7 we have to select. Now here you are having from this C2 5 courses you are having totally, isn't it? 5 courses you have to select. 2 are compulsory. They have to be selected for this. So now how many are left over? Here 3 are left over. So from the 7 courses now you have to select how many? You have to select 3 courses. Whatever 3 courses you want from this 7 courses, you have to select 3 courses. So in what ways can we do this? We'll just see. So selecting 2 compulsory courses from so selecting here, now we are selecting 3 courses to cut out with 3 courses. So from the remaining 7 courses, selecting 3 courses from the 7 courses can be done in how many ways? 7c3 ways. So now in this 7c3 ways means, so what is the answer we are going to get? 7c3 is equal to 7 factorial by 3 factorial into 7 minus 3 factorial, because you know NCR is equal to n factorial by r factorial into n minus r factorial. Using that formula we are doing this. So 7 factorial by 3 factorial into 4 factorial, which is equal to 7 into 6 into 5 into 4 factorial divided by 1 into 2 into 3 into 4 factorial. 4 factorial will get cancelled here. 3 2s are 2 2 will get cancelled. So here it is 35 ways we can select